Hi, everybody, and welcome to this week's lecture. The way that this is going to work is we're going to be breaking it down into three different parts. So in part one, what we're going to try to accomplish today is explaining why water is going to be polar or why it's a polar molecule and how it can form hydrogen bonds. Both of these are going to be connected together because the unique properties of a polar molecule is going to help in the formation of hydrogen bonds. And we'll connect these two and see as to why that is so important when it comes to water. So let's go ahead and look at why water is so important. Why are we looking at this? Why are we studying this? What does this have to do with human life? What does this have to do with biology? Just what is this and why is it important? Well, as you know, many organisms are going to be comprised of majority water. Water is going to be super important. It's going to provide lots of unique properties and characteristics for us, which again help us live and survive. Looking at this over here, you can see that we have a diagram that shows a lot of the functions that water does for people. One of them that I have highlighted is the formation of saliva. Saliva is going to be really important because it is going to aid in digestion. As you know, your saliva not only helps lubricate the mouth, keep the tongue moist, things like that, but it also contains enzymes that help break down your food prior to chewing. It's also going to help flush waste out from the body, specifically urea through pee, and then um, help regulate your bowel movements. It's also going to help regulate temperature. So again, your body likes to stay in a homeostatic area, and if it gets too hot, your body will want to sweat and return back to its comfortable zone. So again, this is going to help regulate body temperature. It's also going to act as shock absorbers for your brain and spinal cord. And that's going to be in the form of our cerebral spinal fluid. Now, essentially what this does is it gives your body a little bit of a buffer zone. So that means whenever your body is experiencing a large impact, because we have our CSF fluid, it's going to allow a little bit more give. So you're not experiencing as much damage. Again, your brain is surrounded by the cerebral spinal fluid along with your spinal cords. Again, they have these pockets in order to prevent serious injury when it comes to large impacts. So as you can see, water is super important. We also have tons of other things that water does for us that help us maintain life. So water, what's up with this water? What is it going on? What's happening with it? What's it look like? Well, we're going to check that out, and we're going to specifically be focusing on the chemical structure. Now, looking at this, you can see this is going to be the chemical equation for water. We have H2O. Remember from last lecture, H2O, the 2 is telling us that we have two hydrogens. So we need 1, 2 to create water. And then when we go to our oxygen, we don't see any subscript, meaning that we only have one oxygen. So in order to create water, we need two hydrogens, one oxygen. And remember hydrogens, this is what that looks like when it comes to the periodic table. You can see we have our atomic number, element, element name, and then atomic weight. And remember, all of these things are going to tell us really important information. It's going to tell us how many protons we have, remember pro positive, how many neutrons we have, remember N neutral, and then how many electrons we have, E electric charge is going to be negative. And again, same thing with oxygen, telling us the same thing. We have our oxygen, atomic number, symbol, and I'm sorry, atomic weight, and then atomic number. Now, based on the information given within these two, it's going to help us build our molecule here. And you can see that we have a covalent bond because we do have sharing between the two elements. So remember, hydrogen is looking for an electron in order to become stable, and then oxygen is looking for two in order to become stable as well. Because of these two characteristics, they're going to go ahead and share in order to create our covalent bond. And then this is what that's going to look like. Now, I do have one more way to represent water, which is going to be this over here. And all this is exactly the same as this representation over here. The only difference is we do not have the orbits and we don't have the electrons. So what this is just showing is how many we need in order to create water. So we have 1, 2 hydrogen, 1 oxygen. And then what these bars are representing is our covalent bond. So we're just showing that they're connecting or bonding together. So now that we've talked about the importance of water, what it does for people, what it does for organisms, and we looked at the chemical structure, what we're going to do now is we're going to be specifically tackling polar molecules. Now, we will cover 2, 3, and 4 in our next parts within this lecture, but what we're focusing on today for part 1 is going to be polar molecules and what that exactly means. Now, water is going to be a polar molecule, and all this basically means is water is going to have a partial positive and a partial negative charge. So the best way to kind of think about this is a magnet. Okay, think about the characteristics and properties of a magnet. Now looking at this over here, again, water is going to be known as a polar covalent bond. The reason why is because we have these symbols here. What this is representing is going to be delta. And all delta basically means is a difference. In this case, there's a difference in charge. So because oxygen contains so many electrons or negative charges, we're going to have a slight negative charge. Now, that's one thing that's really important. Delta means that there is a partial or slight difference. So in this case, this is going to be slightly more negative versus these, which have a delta positive, meaning that's going to be slightly more positive. Okay, so again, a polar covalent bond just means that there's a difference between the charges, positive and negative, and that essentially means that there is going to be an uneven distribution. Okay, so again, oxygen is going to pull the shared electrons much closer. Because it's doing that, it's giving it a partial negative charge on the oxygen atom, which we can indicate right here. And then hydrogen, again, is carried less, so it's going to carry a partial positive because oxygen is pulling the electrons closer. So the main takeaway from this is polar molecules just basically mean that there is a partial positive, partial negative between the two. This funny symbol over here just means delta. Delta just means difference. So there's a difference in charge, and the difference is slightly negative versus these right here. We have delta positive, meaning that we have a slight difference leaning toward the positive side. Okay, so now we're going to go ahead and take a look at water as a polar molecule and then how it's going to create hydrogen bonds. So looking at this over here, we have our water molecule, or I'm sorry, yeah, our water molecule, and you can see it's bonding together with many other water molecules. Now, remember how I said that polar molecules are kind of like magnets. Now, remember that funny symbol? We have a delta. It's either going to be positive or it's going to be negative. Now, when you're thinking about it as a magnet, I'm sure many of you have done this before, where you try to take a magnet and have the same ends and try to make them touch. Whenever you try to push them together, they're going to push away from each other, right? Because they both have the same charges. They do not like this, and they want to repel from each other. But if you take a magnet, a positive and a negative, and find the opposite ends, a negative and a positive, then they're definitely going to want to get together. Opposites attract, they want to magnetize each other, and it's going to be a pretty strong kind of connection. And this is the exact same idea for this over here. So all hydrogen bond is when you take those partial charges and line up the opposite ends, and then they're going to be pulled or they're going to form a bond together. So remember, oxygen, we have a partial negative charge, and then our hydrogens have partial positive charges. Again, we have a partial negative charge here, and then we have partial positive charges here as well. And then when we write all these out, you can see that our positive and negatives right here are binding together, creating our hydrogen bond. And again, you can see we have our negative and our positive over here, again, creating another hydrogen bond here. So the main takeaway from this is because we have those partial charges, they want to bind together. They want to form hydrogen bonds because of that partial and negative charges. So whenever a partially positive and a partially negative element come together, they're going to create that hydrogen bond because they want to come together because of those partial charges. Now, I'm sure I'm wondering, well, why are hydrogen bonds so important? What does it have to do? That's great that they're getting together, but why is that so important? Well, the reason why is because hydrogen bonding allows a very specific and special characteristic when it comes to water. And water is going to flow very smoothly because of those bonds. Again, think about how blood flows. It's really important that water can flow freely and flow past each other and get to point A and point B. A great way to think about this is viscosity. Honey has a very high viscosity, which means that it's very resistant to flow. It doesn't like to get from point A to point B very quickly. Versus water, it's got a very low viscosity, so it definitely wants to flow very smoothly, and it can go from A to B very efficiently. Okay, so again, main takeaway, because we have our partial positive negatives, just like a magnet, they want to get together. So they want to find those ends. When they find them, they create those hydrogen bonds. Hydrogen bonds are going to allow water to flow smoothly. All right. So that kind of concludes our big concepts for this lecture. So what I'm going to do now is I want you to take an opportunity and test your knowledge and see if you can identify some partial positive, partial negatives, and then see exactly if you're able to draw water molecules binding with each other. So go ahead and try 1, 2, and 3. I'm going to give you guys a couple seconds to pause this video, give that a try, and then we'll check it out together. All right, welcome back. So let's go ahead and check out questions 1 to 3 first, and then we'll go ahead and check out number 2. So when it comes to number 1, it says, look at the images from A to D. Which image best represents water? And then what is a way that we can improve this? Now remember, water is H2O. So we need 2 hydrogens and we need 1 oxygen. So looking at that first, we can see every single one of these has 2 hydrogens and 1 oxygen. So we'll give that a check mark. We know that our hydrogen is going to have a partial positive charge. So we're going to go ahead and look through all of those. We have A, negative, negative, so that's not going to work. We have our C, so we have our negative, negative, that's not going to work as well. Looking at this, we have a positive, which works great, but we have a negative here, so that's not going to work. So that is going to give us B. B is going to be the best representation. But it's saying, hey, what can we do to improve this? And that might be a little bit confusing because we already have the positives and negatives, but remember, we need that delta. This delta right here is telling us that we have a difference or a partial charge. So in this case, the way to make it better is we would need to have a delta symbol negative here, delta positive, and then a delta positive. And then just like that, that would tell us that our oxygen has a partial negative charge, and then our hydrogens have partial positive charges. And this actually brings us to question number 3, which is asking true or false. The partial positive or partial negative charges on the oxygen and hydrogen atoms of water are identical to the electrical charges shown in ions. So this one would be false. And one of the big reasons why is because, again, comes back to this symbol over here. This symbol is delta, which is telling us that there is a difference, not an absolute. So in this case, we have partial charges, right? It's partially negative, it's partially positive. So in this case, it's not going to be absolutely positive or absolutely negative. It's only going to be slightly, and that slight change is going to give us unique characteristics. And then moving on to our last one, what this is essentially asking is for you to draw 4 water molecules and then draw at least 4 hydrogen bonds. So remember, going back to our magnet analogy, we need a positive and negative. And remember, magnets want to bind with their opposites, so negative and positive, just the same way as these want to. So remember, our oxygen is going to be delta negative, and then our hydrogens are going to be delta positive. Okay, so in this case, we know we have all of our delta negatives. So let's write those really quickly. And then we have all of our delta positives. Okay, and then when we're drawing this, again, we want to line up a negative and a positive together. So again, you can see our oxygen, hydrogen are close to each other. So that's going to create a hydrogen bond. Same thing over here. We have a positive and negative right here, giving us a hydrogen bond here. Same thing with this over here. We could draw one over here because we would have a positive and negative. In this example, they drew it over here off to the side, which is a positive and negative. So again, the main takeaway from this is, again, like a magnet, you want to make sure the positives are going to go with the negatives. Negatives go with the positives. Make sure you know which elements are going to be what. So remember, hydrogen has that partial positive, oxygen has that partial negative. So in creating hydrogen bonds, these two need to be lined up in order to form them. All right, and that is going to conclude part one of this lecture. So I look forward to seeing everybody in part two. Again, if anybody has any questions, comments, concerns when it comes to this lecture, please feel free to reach out to me. Again, Canvas message is going to be the best way. And please feel free to check out Dr. Kat's videos as well. She has a different way of explaining things. Her video is going to be much quicker than mine. And also check out the supplementary videos as well. Again, I'll see you guys in the next lecture.